Welcome back, everyone, to the Deep Dive. Today, we're diving into a concept that's kind of like foundational to how we understand the world around us, this idea of natural kinds.
Yeah.
And, you might think at first, oh, this is just about like basic categories, the way we label things, but it goes way deeper than that, right? We're going to be looking at whether some of these groupings actually reflect a structure that's inherent to reality itself, something that goes beyond just human ways of sorting things.
That's it. It's this philosophical question, right? Are there these objective divisions in nature
Yeah.
that are categories, scientific, even everyday categories are trying to get at?
Exactly.
Mm.
So for this particular deep dive, we're primarily drawing from the Stanford Encyclopedia of Philosophy entry on natural kinds, which gives like a really comprehensive look at different perspectives.
Mm.
And I think what we really want to do in this episode is kind of give you a philosopher's take on what natural kinds are, why they're so important in all sorts of fields, from, science to language and beyond. And really kind of explore these fascinating ongoing debates. Hopefully you'll walk away with a more nuanced understanding of just, the act of categorization itself.
Exactly.
Okay, so to kick us off, what are natural kinds at their most like basic level? How would we define that?
So at its core, a natural kind is a grouping that isn't, it's not just arbitrary
Right.
or based solely on human interests. Instead, it's thought to reflect this genuine objective structure that's within the natural world itself.
Hmm.
And so you could think that, a lot of people think science aims to uncover these natural kinds,
Right.
to identify categories that correspond to these real divisions that are out there in the universe.
Yeah, so it's not
Mm.
just that we find it convenient to group things together. There's actually something inherently like similar about these things. Like they belong together
Sure.
in a deeper sense.
That's right.
So what would be some like concrete examples?
Hmm.
What are things that philosophers usually point to as potential natural kinds?
So chemistry gives us a lot of what are considered paradigm cases.
Mm-hmm.
So you think about the chemical elements, right? Oxygen, gold, nitrogen.
Okay.
These aren't random groupings. These
Mm.
are defined by their atomic structure. Chemical compounds like water, H2O,
Yeah.
also generally considered a natural kind. Then in physics, you've got fundamental particles like electrons and quarks,
Mm-hmm.
and, even broader categories like bosons and fermions. Then even in astronomy, you look at classifications of galaxies, spiral, elliptical, irregular. These are often, brought up as potential natural kinds.
Wow. So we're talking like, smallest particles to massive cosmic structures.
Right.
But one thing our source points out is that these aren't necessarily like set in stone, right?
Yeah,
Science can change its mind
of course.
about what's a natural kind.
Precisely. And a classic example is like phlogisticated air, which was a recognized kind of thing, right, in chemistry, but was later abandoned with, advancements and understanding of gases and things like that. So science is always refining, always evolving, and as that happens, so do our, categories that we use.
Yeah.
And you see this in the debates about, whether biological species really constitute natural kinds. This is an ongoing, sort of back and forth in the philosophy of biology and in biology itself.
Right. So nature isn't just giving us this like pre-sorted system. We're trying to figure out
Right.
where the real lines are.
That's right. That's right.
And there's this really interesting tension, I think, in the source material that I wanted to bring up, which is this contrast between, we talk about kinds and how stable they are, but then the individual members of those kinds can be, very, very mutable. So can you speak to that a little bit?
Yeah, so that's a really interesting point. So, if you think about like gold, right? You've got individual gold atoms are generally quite stable.
Mm-hmm.
The kind gold persists. But then you look at things like, like a virus. Individual viruses mutate all the time.
Right.
And so this brings up questions about the stability and the kind of nature of the underlying kind.
Yeah.
Because even though, a particular flu strain might be very different a few years down the road, we still think about it as, as the flu.
Right, right. Okay, so this whole discussion, it's not just limited to one area of philosophy, is it?
It's not at all.
The source material mentions metaphysics, epistemology, philosophy of science, and philosophy of language.
Right.
And so how do these different fields kind of engage with this idea of natural kinds?
So, yeah, you've got, the idea of natural kinds is super far reaching. So metaphysics is going to be concerned with like the fundamental nature of these kinds. So are they real? What constitutes them? Do they have essential essences?
Okay.
Epistemology then is going to explore how we come to know about them.
Yeah.
How do we justify our classifications?
Oh.
Philosophy of science is going to look at the role that natural kinds play within, scientific theories and practices.
Mm-hmm.
So are our categories really reflecting, natural divisions?
Mm-hmm.
And then philosophy of language is going to be concerned with how our language refers to and gets its meaning from these, natural kinds, if that's what they are.
Okay, so let's start with the metaphysics then.
Yeah.
What are some of the central questions that philosophers are grappling with here when it comes to natural kinds?
So there are four kind of key, metaphysical questions. So first is, are the categories that we identify as natural kinds truly natural, or are they in some sense a product of our perspective as humans?
Right.
Then second, when we classify things, into these kinds, are we genuinely grouping them into meaningful kinds?
Okay.
Third, what fundamentally are these natural kinds?
Yeah.
Are they these basic parts of reality, or can they be, broken down into something more fundamental like properties?
Right.
And then finally, do natural kinds possess essences? Yeah.
Which are these defining characteristics that are both necessary and sufficient
Right.
for something to belong to that kind?
Okay, so those are some pretty meaty questions there.
Yeah.
So let's take that first one.
Sure.
The idea of, are these things that we're calling natural kinds truly natural, or are they in some way, a product of our human perspective?
Mm.
And the source brings up this contrast between conventionalism and naturalism.
Mm.
So could you explain those two positions a little bit?
Sure. So naturalism, often referred to as weak realism, suggests that there are indeed objectively natural ways
Yeah.
to classify things. So, if you think about, grouping all instances of zinc, right, together, that feels natural and well justified, whereas putting a particular oak tree and the number 7 in Jupiter into a category, seems totally arbitrary.
Right.
Even categories like vehicles manufactured this year reflect our human, practices.
Yeah. Interests rather than deep divisions in nature. So naturalism is just this view that there's a real distinction to be made.
Yeah.
Between classifications that align with, the structure of the world and those that don't.
Okay, so it's kind of in line with this idea of scientific realism.
It is, yeah.
That science is not just, giving us these useful tools, but actually reflecting something real about the world that exists independently of our theories.
Exactly.
But naturalism doesn't necessarily say that every current classification that we're calling natural actually is natural.
Right.
Does it?
Exactly. So, like phlogiston, like I mentioned, right? People thought that was a fundamental kind of stuff.
Mm-hmm.
But it's not.
Yeah.
Even what we used to call jade turned out to be two different minerals.
Right.
And even reptiles, the traditional category of reptiles, a lot of biologists now consider that to be an unnatural grouping from an evolutionary perspective. So naturalism is just saying that there are these divisions out there, but our attempts to identify them, can be either correct or incorrect.
Okay. And so the opposing view then is this idea of conventionalism.
Yeah. Mm-hmm.
What's the main argument there?
So conventionalism, sometimes called constructivism, argues that, natural kinds don't really exist independently of us, right? Of the scientists and thinkers who are doing the categorizing. They say our systems, including those used in science, they're just one way of organizing things, right?
Yeah.
Based on our particular interests and goals, and no one system is inherently more privileged or aligned with some objective joints in nature, so to speak.
Okay. And there's weak conventionalism and strong conventionalism. So what's the difference there?
Right. So weak conventionalism is more skeptical. It says, look, there might in principle be these natural kinds, but our actual classifications are likely not truly natural.
Right.
And this is because we just lack maybe definitive knowledge or the tools to really uncover these real underlying principles.
Okay.
So Locke, for instance, he thought, the real essences of species, if they existed, would be found in imperceptible microstructures.
Mm-hmm.
Right, which you couldn't see with 17th century technology. But then strong conventionalism goes even further. It just denies that there are any objective natural divisions.
Okay.
Whether known or unknown, it's saying, all the similarities and differences that we see are really just a product of, social practices, human concepts, the way we interact with the world, rather than reflecting some like inherent natural facts.
Okay.
So for strong conventionalists, even fundamental particles or chemical elements are in some sense constructed by the activity of scientists.
Right, right. But the source brings up this interesting critique from hacking
Yeah.
using this example of, child abuse versus satanic ritual abuse.
Right.
So how does that kind of challenge this strong conventionalist view?
So hacking is saying, look, even though social constructivism, is right to point out that a lot of our categories are contingent,
Right.
that doesn't mean they're all on equal footing. So he's contrasting this idea of satanic ritual abuse, which was a really powerful social construct,
Hmm.
but there didn't seem to be any real events that it corresponded to.
Right.
Whereas child abuse, which again is also a category that emerged and was shaped by social and historical factors,
Mhm.
it did have real instances.
Right.
And so his point is that while categories are constructed, some can successfully track real patterns and divisions.
Yeah.
And so the mere fact that something's, constructed doesn't mean it's completely divorced from reality.
Yeah, that's such a good distinction, I think.
Right.
So even if something is shaped by social and historical forces,
Yeah.
it can still latch onto something real.
Exactly.
And then we get to this really interesting view, which is Dupre's promiscuous realism.
Right.
And I love that phrasing
It's
there.
a good one, yeah.
Promiscuous realism. So what is that about?
So Dupre's argument is that, the world is really complex,
Mm-hmm.
and there are all these legitimate ways to categorize it,
Yeah.
depending on, what we're interested in.
Right.
So he doesn't think there's just this one, right way to carve nature at its joints.
Yeah.
So for instance, in everyday life, we might classify lilies together as a type of flower.
Uh-huh.
But, from a biological perspective, the genus Lilium actually includes, plants that don't fit our kind of common sense notion of a lily.
Right.
And then the things that we call lilies might belong to different biological genera. So his point is that both of these, both the everyday and the biological classifications are legitimate in a
Right.
way,
Yeah.
but they're serving different purposes. They're based on different criteria.
Mm-hmm.
And he extends this idea, to scientific classifications. So he suggests that even within, a field like biology, you might have different approaches to taxonomy.
Right.
That could be equally valid, depending on what aspect of the organisms you're interested in.
Yeah.
So for Dupre, this idea of finding the one true set of natural kinds, it might just be, it might be a fool's errand.
Yeah, it's very, very pluralistic.
Very much so.
Right. So categorization's not about finding like the one objective structure, but about, creating these useful frameworks
Yeah.
that can help us understand different aspects.
Okay. So let's move on to natural kind realism. And how is this different from the naturalism that we talked about before? So while naturalism focuses on this idea that there are natural groupings and distinctions, right, in the world, without necessarily saying, oh, there's a thing called a natural kind, realism kind of goes a step further. So realism about natural kinds, sometimes called strong realism, is what we call an ontologically committed view. So it's saying that, look, there exist these entities that are the natural kinds.
Okay.
So the difference between silver and gold is not just that there are these two naturally distinct, groups of stuff, but there are these two distinct entities,
Okay.
silver and gold.
The kind silver and the kind
Yeah,
gold.
exactly. So it's not just saying, hey, there are natural divisions, but saying these divisions, these correspond to things.
Right.
The kinds themselves.
Yeah.
And so you can contrast that with nominalism.
Okay.
Right? So just like we have this traditional debate about, realism versus nominalism, about whether we need, universals to account for, shared properties, the debate here is, do we need this special category of entities, natural kinds, to explain, how we talk about natural kinds, how we classify things?
Okay, so the nominalist would just say there are individuals,
Right.
but there's no like kind
Exactly.
that exists, separately.
And they would say, look, you can group individuals naturally,
Right.
but there's no separate entity that constitutes the kind itself.
Right.
And so, the realist is going to say, no, we need these kind entities to explain, why some classifications are natural and others are just arbitrary.
Okay, and we have different kinds of realists, right?
Okay, yeah.
So Quine is mentioned as having this minimal realism. So how does he approach this?
So Quine agrees that kinds are entities, and he thinks they're sets.
Okay.
But he's kind of considered a minimal realist because sets are kind of ubiquitous, right?
Yeah.
Any coherent criterion for classification is going to define a set. So whether it's natural or artificial, so for Quine, the concepts of kind and similarity are super intertwined, and he found it really hard to define one in terms of the other without being circular, but he suggested that, something's more similar to one thing than another if it shares more of its natural properties. But he also was a little bit wary of a general unanalyzed notion of similarity. He thought as science is kind of mature, this vague idea of overall similarity will be replaced by more specific, theoretically grounded notions. So ultimately, Quine's view of natural kinds was quite broad. Any set whose members share a natural property, could be a natural kind. So, the set of all negatively charged particles, that would be a natural kind for Quine.
Okay. And then we have some realists who take a more restrictive view.
Right.
Like cluster kind realism with Boyd and Millikan. What's their perspective?
So cluster kind realists, they build on this intuition that members of a natural kind share natural properties. But they emphasize that it's not necessarily this, fixed set of essential properties. It's more like it's families or clusters of properties that tend to, co-occur in nature.
Right.
And this co-occurrence is either because some of the properties causally influence others, or because there are these underlying homeostatic mechanisms.
Right.
So things that tend to keep, these properties clustered together. So for them, a natural kind is such a cluster.
Okay.
And it allows us to make, reliable inferences. And it provides a basis for scientific explanations.
Okay.
But importantly, they recognize that the particular set of properties associated with a kind, can evolve over time.
Right.
Due to, environmental pressures and things like that.
Right.
And so no one property might be, strictly necessary.
Yeah. Yeah. And Boyd famously uses biological species as a prime example of these, what you call them, homeostatic property clusters, HPCs.
Right, HPCs.
Yeah. So what are kind of the defining features there?
So he thinks, biological species are good examples of this because, they have all these traits that are kind of held together by these homeostatic mechanisms. So, in biological species, these mechanisms can be intrinsic. So, gene flow within a population tends to spread advantageous traits and maintain, some kind of coherence.
Right.
But then they can also be extrinsic. So like the species' ecological niche can impose, these selective pressures that favor certain traits.
Right.
So for instance, a particular body size might be really advantageous for, survival in a given environment. And so that's going to contribute to the homeostatic cluster of properties that we see.
Right. So it's more like a dynamic, collection that's being held together by these forces rather than a set like list of defining features.
Right.
Okay, but there are some problems with this view.
There are. Yeah.
Right.
Yeah.
So what are some of those?
So one big challenge is that the account doesn't really give us a perfectly clear, criterion for what counts as a homeostatic mechanism.
Okay.
Like where do the boundaries lie? When are two mechanisms the same type? Craver, he kind of raises these questions.
Okay.
And then you have, Slater, he's trying to kind of address this by shifting the focus to the stability of the property cluster itself.
Okay.
So he's saying, look, what really matters is the empirical success, Does it support inductive inferences? Does it help with explanations?
Right.
Not necessarily, do we have to, really figure out what the mechanism is?
Right. So kind of moving away from needing to have, a precise definition of the glue that's holding it together, but more just, can we see that it's stable?
Exactly.
Okay, and then we get to fundamentalism versus reductionism. So what's that about?
So this is a debate about whether natural kinds are kind of these fundamental categories in our ontology, or whether they can be reduced to something something more basic, typically universals.
Right, which are these kind of abstract qualities that different things can share, like
Exactly.
redness or roundness.
Exactly. So you've got, fundamentalism, which is advocated by folks like Lowe and Ellis.
Huh.
They think natural kinds are among the basic building blocks,
Okay.
of reality. And then reductionism, this is folks like Armstrong, Hawley, and Bird. They're trying to, explain natural kinds in terms of these more fundamental universals.
Okay, so how do the reductionists go about that?
So Armstrong, he's kind of hesitant to accept a separate, independent category of universals just for natural kinds.
Right.
He thinks that the properties that are shared by all and only members of a kind are usually too complex, too diverse to be these, genuine universals
Okay.
that play this fundamental role.
Right.
But he does make an exception for what he calls basic kind universals, so things like electronhood,
Okay.
where, a small number of properties, mass, charge, spin, are individually necessary and jointly sufficient
Okay.
for something to be an electron. And then Hawley and Bird, they propose that natural kinds are actually these complex universals.
Okay.
So these are universals whose constituent parts are also universals.
Right.
So for an electron, the universal of its specific mass, its negative charge, and its intrinsic spin, these all combine to form this complex universal of electronhood. And this approach allows them to even account for some of the vagueness in, some natural kinds like biological species.
Right. So it's building up these natural kinds from like more basic property universals.
Exactly.
Okay. And what about the fundamentalists then, like Lowe and Ellis? How do they view these natural kinds?
So Lowe, he thinks that natural kinds, which he calls substantial universals, are just an irreducible fundamental component of his ontology.
Right.
And he argues that this basic category is essential for explaining, laws of nature without having to bring in additional concepts like Armstrong's notion of a necessitation relation that holds between universals. He's saying, look, laws of nature are just, fundamentally about the characteristic properties of natural kinds.
Right.
So the law of gravity is about, a property that's inherent to mass.
Right.
Ellis also thinks, natural kinds are fundamental, but he has a slightly different view. He thinks, there are these three levels of natural kinds. So you've got kinds of objects like lions, kinds of processes like photosynthesis, and kinds of properties like negative charge.
Right.
And all of these are universals in his view.
Okay.
And he thinks that this hierarchical view is necessary to account for the hierarchical structure that we see in the laws of nature.
Okay. So that's a good overview of the kind of the lay of the land and the metaphysics.
Yeah.
Now let's talk about essentialism.
Sure.
And what is that about in the context of natural kinds?
So essentialism is this idea that, natural kinds possess essences, which are certain properties that are fundamental and constitutive of what that kind is.
Right.
And the source makes an important distinction here.
Yeah.
We can talk about a particular instance belonging to a kind, essentially. So meaning it's part of its nature to be that kind of thing.
Okay.
But then we can also talk about a kind having essential properties, which are, characteristics that are both necessary and sufficient for something to be a member of that kind. Okay.
And the source makes it clear that a kind having essential properties doesn't mean that a particular individual belongs to that kind, essentially.
Right.
And they use these examples of radioactive decay and speciation. So can you kind of unpack that?
Yeah. So think about an atom of neptunium, right? If it undergoes beta decay, it changes its atomic number and becomes an atom of plutonium.
Right.
So it's kind of changed kind, even though we might think, the underlying matter persists. And then similarly, in biology, a new species can evolve from an existing one through reproductive isolation. So, organisms might belong to this ancestral species,
right,
and then their descendants belong to a new species.
Yeah.
So even though we might, argue that having 93 protons is essential for being neptunium, an individual atom can transition between these kinds.
Mm-hmm.
So that shows that essentialism about kinds doesn't automatically lead to essentialism about, an individual's membership in those kinds.
Right, right. Okay. Now the arguments for essentialism, in the context of natural kinds, often come from Kripke and Putnam, and their work on the semantics of natural kind
Yeah.
terms.
Yeah.
Particularly this idea of a posteriori essentialism.
Right.
So how does that work?
So it seems kind of paradoxical, right? This idea that something we discover through experience is nonetheless necessary.
Yeah.
But this is really kind of a central idea in contemporary philosophy. So Kripke and Putnam, they argued that certain identity statements involving natural kinds, like water is H2O, host speaker,